Alright, today we're moving on to part 2 of Quadrilaterals and Properties, and I don't think I've taken a second to read this cartoon to y'all. It says I start every song by counting 1, 2, 3, 4 because it reminds me of math. Math depresses me and that helps me sing the blues. I hope that's not true for many of y'all. It's definitely not true for me, but I thought it was a cute cartoon. Okay, in 304 we're going to identify the relationships among special quadrilaterals and among their properties, and then we're going to use the properties of special quadrilaterals to solve problems. Okay, if y'all remember back to Euler diagrams, you remember the hypothesis is always in the small circle, the conclusion is always in the larger circle. Well, in this lesson they're going to go into that a little bit more. And please read in the LMS because they really go into it. I did get this out of the LMS because I like the way that they color coordinate everything. This first sentence, if a figure is a square, then it is a rectangle. We'll see how a figure is a square is in the orange and it's colored orange. It's a rectangle is in the green circle and it's colored green. A figure is a rectangle, still in the green, then it is a parallelogram, is in the blue. Well, if a figure is a parallelogram, then it's a quadrilateral. So you got that in the blue and the quadrilateral in the purple. And then you come down to this last one, and it says if a figure is a square, way down here in the little circle, then it's going to be a quadrilateral. A rectangle is a quadrilateral, parallelogram's a quadrilateral. Anyway, I just thought that was a real good illustration in the LMS, but they're going to talk to you a little bit more about the Euler diagrams and how they're used in the LMS. I want to get into working some examples for you using algebra because that's where most of the students start. You got to remember the properties of the quadrilaterals and you got to remember how to do the algebra. Okay? So, this problem says in the isosceles trapezoid ABCD, AB is equal to CD, segment AD is parallel to segment BC, and the measure of BCD is 121 degrees. Well, notice how I went in and I marked up the picture. I said these two guys were parallel. I said these two guys were equal to each other, just like they did in the problem. And then I said the measure of angle BCD is 121. Well, notice that BCD, which I probably should have put this too, I'm going to put it now. Notice that BCD is the larger angle. Okay, that's not really on there like it should be, but y'all get the idea. Alright, so it's that large angle that I just outlined in red there. That's what's 121 degrees. Alright, they want to know the measure of angle DAB, so let's find DAB. Here's DAB. So they're wanting to know the measure of that angle. Well, this right here tells us that the base angles of an isosceles trapezoid are congruent. Now, what makes this an isosceles trapezoid is the fact that the legs are the same size. And base angles of this trapezoid are going to be congruent. Okay, so that means this angle right here is going to be congruent to this angle right over here. Now remember, now I'm not going to say that. Let's go ahead and work through the problem. We got the measure of BCD, measure of angle BCD right here. See where I got my green line? That means it's going to be congruent to CBA. Alright, since this one's 121, that means CBA is also going to be 121 degrees. Okay, the measure of CBA plus the measure of DAB are going to equal 180 degrees. So all we got to do is plug and chug here. We're going to put in 121 degrees for angle CBA. We don't know DAB yet, and we know they equal 180. So what they're going to do now is subtract this 121 degrees from both sides. So we find out that the measure of DAB right here is going to be 59 degrees. That's how you work that out. Okay, for the measure of angle ABC, oh, look at my little things are all, I moved my picture and I forgot to fix all that. Remember, the base angles of an isosceles trapezoid are congruent, so this says ABC. And since it's congruent, let's see what happens here. Oh, I just said the measure of angle ABC is 121. So the measure of DCB, is that what they called it? Oh no, they called it BCD, is 121. Since base angles are congruent, this angle right here is 121, so ABC is also going to be 121 degrees. Okay, measure of ADC, we got ADC. The base angles of a trapezoid, isosceles trapezoid, are congruent. We already know the measure of this angle right over here is 59 degrees. So that means the measure of ADC is also going to be 59 degrees. Alright, in this one it says parallelogram UVXY, WY equals 10 millimeters, YU is 16 millimeters, measure of angle XYU is 75 degrees, measure of angle XVY is 35 degrees. Well, it tells us to find all these measures, but I said before we start solving, let's mark up the picture with what we know about parallelograms and what the problem tells us. So look what I did here. Bam! It's a colorful parallelogram now. Remember, opposite sides are parallel, opposite sides are congruent. See how I marked them all? Congruent, congruent. Alright, opposite angles are congruent. See how I mark those? Okay. Also, the diagonals bisect each other, so that means this segment's congruent to this segment. This segment's going to be congruent to this segment. And also, consecutive angles will always add up to 180 degrees. Okay, so that's, there was no really way to mark that one, so I'm just telling that to you. I'll also mark the angles. This little angle right here is going to be 35 degrees. Okay. This angle down here, this XYU, is 75 degrees. Okay. Don't let those lines mislead you. I put those lines in there to show you that opposite angles were congruent. So if this angle right here is 75, this angle right here is 75 degrees. If I want to find out what UVW is, I'm going to take 75 minus 35. Okay? Alright, so let's, oh, and look, I put the measure of the segments down here. This YU is 16, WY is 10. So we're going to find out the measure of VY. The diagonals of a parallelogram bisect each other, so let's find VY. I'm going to draw it in here. VY. I'm having a hard time finding it. Oh, VY. Right there. The whole thing. Well, look at this. If we know this side of it, WY equals 10, that means WV also equals 10. So look here, I put VY equals 2 multiplied by WY. 2 times 10 equals 20. You could have also said 10 plus 10. Or WY plus WV equals, you know, and solved it that way. Next, they want to know about XV. Let's see where XV is. I like to mark it up, you know. XV, it's this one right here. Well, we know that opposite sides of a parallelogram are congruent, so if YU down here is 16, that means XV will also be 16. So I put XV equals YU, so that means XV, and I substituted 16 millimeters for YU. It's that easy. Okay, the measure of angle VYU, let's mark it up. I like to do that. V, where's V? V to Y to U. There you go. They want to know what is the measure of that angle right in there. Okay, now this can be kind of tricky. We know this whole angle right here is 75 degrees. That means this whole angle is 75 degrees. Another little special thing is that we know that since this angle right here is 35 degrees, that means this angle is 35 degrees. Okay? So I put measure of angle VYU equals the measure of XVY, and that would be XVY. So that means the measure of angle VYU is 35 degrees. Okay, the measure of YUV, oh, I gotta mark that up so I can see where it's at. YUV. Now remember that consecutive angles of a parallelogram are supplementary, so we can come in and we can say, okay, that means this angle right here that I'm highlighting in yellow is going to be its supplementary angle, and we know it is 75 degrees. So you can put in there that the measure of angle YUV plus XYU is going to equal 180 degrees. XYU we know is 75 degrees, so we just plug that in for that angle measure, and then we subtract 75 from both sides. We're going to get the measure of YUV is 105 degrees. Okay, the measure of XVU, let's find XVU. XVU. Oh, we know that whole angle is 75 degrees. Just so you know. We know this part of it's 35, but we know the whole thing is 75 because opposite angles are congruent. Okay? So I just told you the answer. Plain as day. We know that XVU equals XYU. The measure of XVU then is 75 degrees. Okay, let's look at YVU. Let me change these colors. That yellow kind of throws me off. YVU. It wants to know the measure of that. And you got to remember that opposites are congruent. Remember what I told you earlier, since we know this angle right here is 75, that means this whole angle over here is 75. Well, 75 minus 35 is going to tell me the measure of YVU. So I put the measure of XVU as 75 degrees. What else did I put? Okay, whew. So I know that XVY plus YVU is going to equal 75 degrees. So I plug in 35 degrees. I'm going to subtract it from 75. So the measure of angle YVU is going to be 40 degrees. So see how knowing all the properties of this parallelogram helped us solve all of these measures. It's just a big puzzle. That's all it is. That's the way you need to look at it. The summary in this lesson is you can use Euler diagrams to depict the relationships among special quadrilaterals, and you can use the properties of special quadrilaterals to solve problems that involve their measurements. You need to go through and read the LMS because it's got a little bit more information that I gave you in the video. I just hit the highlights. Please complete the student guide. That's going to be the notes you can use for your test. Be sure to read 65 through 68 in your reference guide and work these problems in your problem set because they're just like the examples I just showed you. Almost all of them are. And please contact me or attend TOGA before you try to attempt the quiz if you've got any questions. And that's it for quadrilaterals and their properties. Thanks.